linear data structure. So first point is the linear data structure. Q data structure is a linear data structure. Okay, and Q is called fast in, fast out data structure. Stack is last in, first out. LIFO. Stack is last in, first out. Why last in, first out? Any idea? Stack is last in, first out.
Because
Because the
the last element that we push is
is
the
popped
only
out.
one. Yeah.
Is the first element that is popped out. That's why stack LIFO. LIFO is stack and FIFO-DS is the queue. Okay. Now queue stack is in case of stack one end is bounded. Okay, there is only one open end in case of stack, but in case of queue there is two open ends. First end is called the front and second one is called the rear. So if this is a queue data structure, so this particular end is called the front F and this one is called the rear. Okay, now the first, why this is called the first in first out? Any idea? First in first out.
Sir,
Sir,
popping is done from the front end. So
and
Popping is
inserting is done at the rear end.
inserting is done at the rear end. Okay, so rear end is used for, so rear is used for insert, that is NQ. This is called the NQ and deletion means DQ. Okay, and the front end is used for delete, that is DQ. So it is called the first in first out data structure where the element that is inserted first is the first one that is taken out. Okay, suppose the list is, suppose the this is 10, 5, 9, 11. Okay, so this is your queue. So we have to learn about the queue implementation using array and linked list both. Okay, so first of all, queue implementation using array. So if Q is the array name, Q is the array name. If Q is the array name, then how to insert at the rear part? Any idea? Anyone?
Sir, so rear plus one, then we insert the value at the
Rear position.
rear at that point. Yeah.
So we have to first we have to declare the front and rear. So these are two variables. Okay, so front is equal to -1 initially and rear is equal to minus 1. Okay, initially. So this is your initialization of these two variables. We are now going to discuss about the array implementation of queue implementation using array. So int this. These are two variables. So first of all, insert. So insert. So insert function. So inside the insert function, that this is void insert. Okay. Now, suppose your value is n. Okay. That this is the queue structure 10, 5, 9, 11. We have to insert 20. We have to insert 20. So what should we do? We have to first make a room for this 20. Okay. So we have to increase at the rear part. Then we have to insert that 20 at the newly created room. Okay. So this is your n. This 20 is your n. So int n. And then just write your enter your value. Enter your value. Okay. And scanf. Your value is n. Your value is n. Now, first of all, we have to check what is the overflow condition. If your rear is equal to max minus 1. If your rear is max minus 1, then just write the message that your queue is full. We have to define the max. Okay, so we have to define the max. So how to define? Has defined the macro. Has defined your max, our max, let our max size is 10. Okay, so queue is full. If your queue is, so this is the full queue condition. Okay, so this is the full queue. This is the full queue condition. What is the empty queue condition? Any idea? Empty queue condition?
Rear and front
to
equals to
minus
-2.
Rear and front is equal to
-1.
-1 because we initialize our rear and front variable to -1. So else if our front is equal to -1 and rear is equal to -1. There should be and. Okay, your front and rear both should be -1 at the same time, and so this is the empty queue condition. So this is your empty queue condition. So what should we do in case of empty queue? So we have to just increase your front and rear. Front, rear, 0. Otherwise, that is not empty. So first of all, increase your rear and your Q, the array Q and rear is equal to your N. Okay. So this is the insert function. This is the insert function. So insertion always be done at the rear end. First of all, we have to increase the rear so that a new, yes,
Sir, the last line should be out of else.
yes,
Yeah, like it should
that
be out of else. Yeah.
that's why there the single line means no need for braces. Okay. So else rear plus plus, and finally this value n, that is 20, is inserted at the newly created room in your Q array. Okay. So this is the insert function. So if you are asked to write down the insert function, that is NQ. NQ means insertion. NQ. If you are asked in your exam to NQ to describe the NQ using array, then first of all you have to write down the algorithm or code fragment. This is the code fragment. Okay. And with the pictorial description, you have to describe the NQ process. Okay. Now what is the DQ process? Delete, just like pop. So is returning an element, int delete. So delete should be done at the front end, right? So what is the empty queue condition? Your queue is totally empty.
So front equals to -1.
If
Rear equals to -1.
front is equal to -1, sorry, -1. If front is equal to -1. If front is equal to -1, or your front is greater than your rear. If your front is greater than is equal to rear, suppose this is 0, 1, 2, 3. Okay. So size is 4. Q size is 4. Here in our example, Q size is 4. Now, if the front is -1, if it is -1, then this is the underflow condition, one underflow condition. And another underflow condition is that suppose your front is at this position, and rear is at this position. So rear is less than front. If rear is less than front, then this is the underflow condition. This is one underflow condition, and another underflow condition is front is equal to -1. Okay. So then we have to return -1. Otherwise, that is Q is normal. Q is normal. Then we have to store the first element, that is 10, in our example 10, in a particular value. Okay. Then we have to increase the front. So here this is your front. So you have to increase this front in the next index. So front will be now at 1. Front plus plus. Okay. And then you have to return the value. So this is the condition for delete an element. So suppose I'm writing the algorithm. Step 1. Step 1, delete. Delete an element from a queue. Delete an element from a queue. Step 1. So if front is equal to -1 or your front is greater than your rear part, then just print underflow. Okay. Otherwise, that is your queue is not empty, underflow. So n is equal to n. N is equal to, we have to copy the first element to the n. So q, first element. So first element is your front. So first element is copied in the n. Okay. And then just front plus plus. Okay. So this is the exit. So this is the deleted element from the queue. Deletion an element from the queue and insert an element in a queue. So insert an element in a queue that is at the rear part and delete an element from the queue that is at the beginning part, front part. So this is the array implementation, queue implementation using array. Any doubts?
No, sir.
So queue implementation using array and queue implementation using linked list. How can we implement a queue using linked list? Any idea?
Sir, it is normal linked list implementation where we will be inserting at the end and deleting at the front.
Deleting
from the front.
deleting from the front. So
Normally plus.
so first of all, you have to your queue. We are using the single linked list. Okay. So first of all, in a single linked list, there are two parts, right? First part is the node. The first part is the data part, and the second part is the pointer part. Okay. So first of all, our task is to define the node structure. So every time you have to define the node. You have to define the node, and the node is, we are using the structure. So struct node. The first part is the data part, and the second part we know that as the self-referencing structure. So struct node and the pointer. So this is your node structure for the queue. Okay. Now here, as the queue has two pointers, every queue has two pointers. First pointer is the front pointer and second pointer is the rear pointer. Okay. Along with that, along with the node definition, that is struct node int data and struct node star next, there we have to define also the queue structure. Why queue? We have to define queue structure. Any idea? So this is the node structure, and we have to define the queue structure now. So let the queue structure is queue. Name is queue. Okay. So this is the structure. Struct queue. Because it has two pointers. First pointer is your front pointer, and last pointer is the rear pointer. We have to insert through the last one, that is rear, and we have to delete from the first one, that is front. Okay. What will be the return type of these two pointers? Any idea?
Struct queue.
Is it struct queue?
So like it should be struct node, but I don't know why you made this new structure.
Because you have to define a pointer variable of this queue structure. You have to deal with that particular pointer variable, right? That's why struct queue. So struct, so that we can define struct queue. Struct queue. That this is small q. Struct queue. Queue. So this front pointer and rear pointer comes from the queue structure. You have to define the pointer of this queue structure. This particular queue will contain the front and rear, right? Every node is of this structure. So that's why this pointer, return type of this pointer is struct node and struct node rear. Now you have to suppose queue front. Queue front is equal to let null, and Q rear is equal to null. What does it mean? Q front is equal to null and Q rear is equal to null.
So we are making the front and rear part null.
Yes. So what is the analogous part in case of array implementation?
Sir, making it -1.
-1. Front is equal to -1 is equal to rear. That is front is equal to -1, rear is equal to -1. That's why we are dealing with the pointers. So Q is the pointer variable coming from the struct Q. Your Q has two parts, front part and the rear part. Okay. And this front is of node type. Your front is of node type. Your front pointer and rear pointer are of node type. And every node has two parts. First part is the data part and second part is the pointer part that points to the next node. Suppose this is 1 and this is 2. Let this is your 3. So this is the last one. So from 1 to 2, from 2 to 3, there is a link. So initially, this should be your front F and this should be your rear. Is it clear? 1, 2, 3. 3 nodes are there. And every node has two parts. First part is your data part and second part is the pointer part. That's why this is the node structure. This follows the node structure. And this is your entire queue. Shourashish, this is your entire queue. Which queue has two parts? First one is the front part and second one is the rear part. But the return type of the front and rear is the struct node. So struct node pointer front and struct node rear pointer. Is it clear?
Yes, sir. It's clear. Sir,
Now,
I just
yes.
had a question.
Okay.
Sir, not making it this much complicated, we could have just implemented normal SLL. They're also just uh, inserting at the end and deleting from the beginning is only
Yes,
Q.
you can. Yes, you can do that also. But the essence should be correct. You should follow the proper grammar. Okay. Insertion should be at last one. Should be from the last one. That is rear part should be increased. Okay. And deletion, for deletion, your front should be increased. Every time you have to increase two pointers. Either front for deletion and for insertion, that is rear. Okay. Now suppose the new node is 4. Okay. So how can we insert at the how can we insert this 4? So first of all, we have to dynamically allocate this new node. Okay. Then we have to insert the 4 at the data part of the dynamically newly created the new node. Okay. and then what should we do? Any idea?
Sir, we will have to uh, like uh, rear next should be connected to the new node.
Yes, rear next should be connected to the new node.
And
Okay,
rear
so
equals
rear next is connected to the new node, so that's why I omit this one. And your line should be rear q rear next, because we are using the q variable. So q rear next is equal to your new node, and then and then your new node is becoming the last node, that is rear node. And finally make the last part of the last node is null. So there are three operations. First operation is the make a connection from the existing rear to the new node. Second one is the make the last node, that is the rear new node is the rear node. And the third operation, what is the third operation? Third operation is the last part of the new node is made null. Okay, is it clear?
yes, sir.
So three operations are there. So first of all, uh, struct node, struct node, new node. Okay, struct node, new node, and struct node, new node, and you have to dynamically allocate the new node. So new node. How to dynamically create a new node? Any idea? Any idea how to?
Uh, I don't. Data type will be Q. So no.
Struct node.
Achha. Then malloc
Not Q.
malloc
Yes.
size of struct.
Malloc.
Size of struct node.
Size of struct node. The return type, Chodashish, the return type of the new node, the return type of the pointer, that is the your front pointer, rear pointer, both are same. The return type is struct node. Okay,
Okay,
because of self-referencing structure. Every node, every front pointer, every rear pointer have two parts. First one is the data part, and last one is the pointer part, next part. Okay, so new node is dynamically created. Okay, and the data part of the new node, so new node at the data part, what happened? Data part of the new node, at the data part of the new node, insert the value. Here in our example, the value is 4. Okay, so our value is 4. That is insert 4. Then q is created. What is q? Q is of type struct q. Okay, we are taking this q in a structure, and it has two parts. First one is the front part. Just this is your q, this is your q, this entire one is your q. So it has two parts. First one is the front part, and second one is the rear part. This front and rear are of type struct node, because it has front and rear has two parts, data and next part. So q, so the first, so this is the first operation. What is the first operation? Last part of the rear. So the last part of the rear is the new node. Shodashi, this is the step first operation.
yes, sir.
Last part. So initially the last part was null. Last part of the rear is pointing to the new node. So what should we write? So q Q is the Q. So Q and ADR. Okay. So you are at the last one. Its next part. Its next part is your new node. Right? Is it clear? Is it clear to you?
Yes, sir.
So this is the last part, that is rear node, and rear node's next part is now pointing to the new node. And your new node, so second operation is the new node is now becomes your rear. So your new rear is at the last position. So what should we write? Q. Sorry, it should be small q. Q rear. So Q rear is equal to new node. Okay. So this is the second operation. And what is the third operation? So this is your, now after the completion of that particular line, that is QDR is equal to new node. So R is now pointing at this position, the last node. Now could you please suggest what should we do to make the last node's next pointer to null? Any idea?
Q rear next equals to null.
Yes. So first one is your Q rear. Q rear. And then its next position is equal to your null. So this is the code for existing. This is the code for non-empty queue. Okay. Suppose the queue is totally empty. Then what should we do? We have to increase the front and rear. We have to increase the front and rear, and there is only one element. That particular element is your new node, and make the last part of the new node to null. Okay. Now the deletion is your homework. Deletion is the HW. You have to delete from the first one using the linked list.